Square root property says you can take the square root of both sides. You just have to know that your answer could be positive or negative, which I'll explain why in a second once we actually work this one out. So if you take the square root of both sides, you get x equals plus or minus the square root of 245. The reason it works to be plus or minus is because if it's positive, if you square it, then you still get back to itself. But if it's negative, right, then a negative times a negative is still a positive. So that's why you get two possible solutions, positive or negative. Now, the only thing you have to worry about is you always have to simplify your radicals. And this radical does actually simplify. So if you think of that list of perfect squares that we made earlier, the 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. I'll stop there, so I'll tell you it's one of those numbers. See if you can figure out which one divides evenly into 245.
49.
And feel free to use a calculator if you need to. I hear an answer though.
49.
49, yes. And I could certainly understand if you needed a calculator to do that. That is not something I expect you to do off the top of your head at all. Okay, how many times does 49 go into 245?
5 times.
5 times. Then you have to simplify. What is the square root of 49?
7.
7. And then that's your answer. Plus or minus, which there is a plus or minus button in my math lab, plus or minus 7 times the square root of 5. You might see them list the answer like this, by the way, 7 times the square root of 5, negative 7 times the square root of 5, which is also correct, but it's not necessary. So you can enter it like this, or if you want to list it like two separate answers, that's also fine. Either answer should be accepted. So what would you do first in number 49?
You would add the 57 to both sides.
So you need to get whatever is being squared by itself as your first step before you apply the square root property. So I agree with you. You want to add the 57 to both sides as your first step. So now 3z squared equals 57. Now whatever's being squared is still not completely by itself because it's being multiplied by 3, right? So how do we undo being multiplied by 3?
Divide by 3.
Exactly. So we divide by 3 on both sides. So what does that give us?
19.
And now how do we solve for z? If z squared equals 19, how do we solve for z?
Square both sides.
Take the square root of both sides. And what does that give us?
Plus or minus radical 19.
How about number 50?
You just square both sides because it's already in the correct form.
Exactly. Already, whatever's being squared, which in this case is the x plus 9, is by itself, right? There's nothing else extra there. So your first step is to take the square root of both sides. Very good. When you take the square root of something that was being squared, you just get the original thing, right? So x plus 9 equals plus or minus, what is the square root of 16?
4.
4. Now be careful here. The next step could be to subtract. There's two ways to do it from here. So one way is you could subtract 9 from both sides, but I would recommend writing the 9 first. So negative 9 plus or minus 4, and then work it out, right? What is negative 9 plus 4?
The negative 5.
And then what is negative 9 minus 4?
Negative 13.
The other way you could have done it instead of solving it together is created two equations. So you could have set up the equation x plus 9 equals 4 and x plus 9 equals negative 4 and then solved both equations by subtracting 9 from both sides, and you would have gotten the same answers that we did the other method. So complete the square. You're trying to create a perfect square trinomial, which it might feel like a random process now, but you will see that it helps you to solve equations. Because if you think about it, quadratic equations, when we first studied them in the last module, they always were factorable. But every quadratic equation that you actually encounter is not always possible to be done by factoring. So we had to establish some other methods that you could use to solve them. So one of them is the complete the square process. And then the complete the square process actually helped us to derive the quadratic formula. So even if you're not a fan of complete the square, the quadratic formula would not exist if someone had not figured out that complete the square works. So it's kind of cool if you think about it. It also helps when you get into studying different shapes like circles and ellipses and things like that. It's helpful to have an understanding of the complete the square process. So it does come up again if you go into like pre-calculus, you might see it again there. You'll see it in college algebra also, but you'll see it applied more when you get further along. However, there is a formula you can use, which is if you have like x squared plus bx, the trick is that you always take the b value, divide it by 2, and square it. And that's going to be your constant. To take your b value, whatever the coefficient of x is, divide it by 2 and square it. And then on the other side, that's always going to equal the number you got when you divided by 2. So x plus b over 2, and then all of that squared. So this is the formula. You can also get this other side by factoring. So I'll explain that when we work through the problem. So m squared plus 22m. 22 is your b value. So we're going to take 22, and the first step we're going to do is divide by 2. So what is 22 divided by 2?
11.
I think I heard it.
Yep, 11.
11. Okay, my computer must have cut out. Sorry. And then we're going to square that. So what is 11 squared?
121.
That's what we're going to add here. So now pretend you don't know the complete the square rule and all you know how to do is factor. How could you factor that? What are two numbers that multiply to 121 and add up to 22?
11.
11 and 11, right? So couldn't you write this, if you didn't know anything about complete the square, but you just knew how to factor, you might say, okay, so this is really m plus 11 times m plus 11, right? And isn't that the same as writing m plus 11 squared, correct? Just from your knowledge of factoring. However, if you look at the formula I gave you, which you can memorize if you want to, it says that it's always going to factor as x, or in our case m, plus b over 2 squared. Well, sure enough, what did we get for b over 2? We got 11, right? So it works by factoring or by using that formula, whatever number you got when you divide it by 2. Okay, I like to show that because that way when the numbers are reasonable, it's nice to know that it's okay if you just factor to figure it out. Sometimes the numbers get messier and you're dealing with fractions and things like that. I don't really recommend factoring with fractions, so it is good to know the rule that it's always whatever you got when you divide it by 2. But I like to show that it connects. They're not two separate concepts. They're actually overlapping. They relate to each other. Questions there? Okay. So let's try number 52. Let's actually apply this process to an equation. So the first thing we need to do is I'm going to subtract 76 from both sides because I want to have just the terms with the variable alone on the one side and the constant on the other side. And now I want to figure out what to add here. But if you think about an equation needing to be balanced, whatever you add on one side, you also have to add on the other side, right? Just like you always do when you're solving an equation. Whatever you do to one side, you do to the other side. So let's figure out what number we have to add to both sides. So you want to take the b value, right? What is the b value here?
Positive 18.
Good. Then you want to divide it by 2. So what does that give us?
9.
And then you want to square that.
81.
So we're going to add 81 to both sides. Okay, now what is negative 76 plus 81?
The
On the right
negative
side.
58.
Negative 76 plus 81?
Oh, negative 58? Did I do that wrong? No, I did that wrong.
Yeah,
Sorry.
it's not 58.
It's
5?
negative 18. Positive 18.
No, I agree with, I think Caitlin said it. I'm not sure, but it's
Oh, hi.
5.
My calculator skills are failing me today.
Oh, you are fine. No worries. You're just trying to keep us all on our toes, right?
Yes, there you go.
That's what I like to say if I make a mistake. I was just seeing if you were paying attention, right? Were you paying attention? Okay, it's a nice excuse. Also, maybe a little bit of a lie, but that's okay. How about the left side? You can either factor it or use the trick that I was showing you with the formula. So how would you write it as something squared?
Would that be an x plus 9 squared?
Very good. So if you're trying to factor it, you're saying what numbers multiply to 81 but add up to 18, which would be 9 and 9. So you could write it as x plus 9 squared. Or you're using the formula, which says you always use the value that you got for b over 2. Okay, now what you've actually done is set up a problem where you can use complete the square. Or not, sorry, you've done complete the square. You have set up a problem where you can use the square root property. So these problems kind of combine both, right? You have to do complete the square initially, but then you have to do the square root property to finish out the problem. So now we're going to take the square root of both sides. So that gives us x plus 9 equals plus or minus the square root of 5. And then what would be the last step?
Just subtract the 9 on both sides.
So I would write it as negative 9 plus or minus square root of 5. And you can enter it like that. You do not have to enter it as 2 separate answers. Okay. Any questions there? Because I know this is a complicated process. No? Okay. Let's check out number 53. Unfortunately, what do we need to do first in number 53?
You got to divide by that 9.
Yep, you cannot have a coefficient in front of the squared term. So we have to divide every term by 9. Doesn't matter that it's nasty. We are required to do it as our first step. So this becomes p squared minus, now 30 over 9 does reduce, and I do recommend reducing it because there's no need to deal with the really big numbers. What little number goes into 30 and 9?
3.
3. So we can reduce that down to 10/3, right? To at least make the numbers a little more manageable. Plus 19 over 9 equals 0. Then we have to do like last time, right? And get the 19 over 9 on the other side. So now we have p squared minus 10/3 p plus, we have to figure out what to add there, equals negative 19/9 plus whatever we decide to add. So how do we figure out what we have to add on both sides?
You divide the negative 10 over 3 by 2.
Which is a little bit tricky. 2 is the same as 2 over 1, right? And when you're dividing, if you recall, that's the same as multiplying by the reciprocal, or you can think of this as a keep, flip, change problem, right? So we're going to keep the first fraction the same, right? And then find the reciprocal or flip over the second fraction. So the 2 over 1 becomes 1 over 2. And now we're going to multiply. So what does that give us?
Negative 10 over 6.
Which simplifies because 2 goes into 10 and 6. So it reduces down to what? I didn't quite hear you. I think someone answered, I just didn't hear it. What does that reduce down to?
5 over 3.
Good, negative 5 over 3. Now we're still not done. Now we have to square that answer. But the good news is when you square it, you're just squaring the top and squaring the bottom, right? So what is negative 5 squared?
25.
And then 3 squared?
9.
9. So at least that part is a little bit better. Now we're going to take that number and do what with it?
Add it on both sides.
Good. Okay, on the right side, I like to start with the right side when it's easier. We can go ahead and add the negative 19 and 25 together, just knowing our denominator is still going to be 9. So what is negative 19 plus 25?
44 over 9.
It's not 44 because the 19 is negative, but the 25 is positive.
6.
6 over 9?
6. Good. Now on the left side, this is an example of a problem that I probably would not want to factor because I personally am not very familiar with what multiplies together to 25 ninths and adds up to negative 10 thirds, right? That's not a factoring problem I really want to have to do. So this is when it's helpful to know the rule, which is that you can always use what number?
2.
So it's going to be something squared, yes. But how do you know what goes inside there?
The negative 5 over
Would it
3.
be P minus 5/3?
Exactly. You both got it. Very good. You can always use the number you got when you divided by 2. So P minus 5/3. But we're still not done. These are long problems, right? What do we have to do now?
Square both sides.
Take the square root of both sides. So now the square root of P minus 5/3 squared, that cancels out. You just get P minus 5/3 plus or minus. The square root of 6 does not simplify, but what is the square root of 9?
3.
3.
3. Okay, so we're almost done. What can we do now to get the P by itself?
Add negative 5 over 3 on both sides.
So add 5 over 3 to both sides because it is negative. Yep. So 5/3 plus or minus root 6 over 3, or you could actually combine it, right? Since the denominators are the same, you could say 5 plus or minus the square root of 6 all over 3. Any questions there? I know that's pretty complicated, but we get to do one more together before we move on to the last concept. We're getting close to the end. Make sure for these problems you read the instructions, right? So what are the instructions for number 54?
Complete the square.
Complete the square. So what do you have to do?
Divide by 9.
Exactly. You have to divide by 9 and we'll do it together. You have to do the complete the square process. Whereas what are the instructions for number 55?
Using the quadratic formula.
You could do either of these problems by either method, right? So technically speaking, you would be able to solve number 54 by doing the quadratic formula, or you'd be able to solve number 55 by doing complete the square. But it is important that you follow your instructions. I'm not 100% sure what Mrs. Sarsig does, but I know many instructors look to make sure that you follow the instructions when they check your work paper. So just keep that in mind. Okay, so I agree with you. We're going to divide by 9 again. This one's very similar to the last problem, actually. Once again, it simplifies to 10/3, so I feel like a lot of ways we don't have to start from scratch here because it should remind us a lot of the last problem. So what do we do next?
Add 28 over 9 to the other side.
So now we have y squared plus 10/3 y plus blank equals 28 over 9 plus blank. Now I'm going to cheat a little bit. Since we just used 10/3 in the last problem, it just happens to be positive instead of negative, right? But that doesn't change much. What is going to happen? Well, when you divide it by 2, you're going to get positive 5/3. When you square it, you're going to get positive 25/9, right? So it's basically the same process we just did. So I'm going to go ahead and skip a step if that's okay and just fill it in here. Right, so I'll write the results, but I won't show the work. So B was 10/3. So based on what we just did a minute ago, B over 2 would be 5/3, just without the negative from last time. And then when you square it, it'd be 25/9. So you could work it out again, but we just did it a minute ago. Okay, so now on the right side, what is 28 over 9 plus 25 over 9?
$53 over 9.
Very good. And then on the left side, how does that factor as something squared?
It's y plus 5 over 3.
Good. So you always use the number you got when you divide it by 2. Okay, how would you finish out this problem?
Square both sides.
Take the square root of both sides. So now you have y plus 5/3 equals plus or minus. The square root of 53 does not simplify, but what is the square root of 9?
3.
3. So it's very similar to the last problem, right? What's the last thing we have to do?
Bring the 5/3 over to the other side.
So subtract 5/3 from both sides. So negative 5/3 plus or minus square root of 53 all over 3. Then, since the denominators are the same, you can go ahead and combine the numerator if you would like.